All right, the next lesson is over solving equations. Sorry, that's the bell. I did not just curse and it edited me. The last lesson we were talking about expressions, and now we're actually going into equations where we're actually going to solve these. So we're going to be solving multi-step equations, proportions, and equations with fractions. And that's the equation with fractions is where it's going to get a little bit difficult. So hopefully you guys are pretty decent at this from Algebra 1 by now. But just in case, this first example, we need to distribute. When we see parentheses, that 8 multiplies by both the 2x and the 7, so that's 16x plus 56. Now, I always put a dotted line, or I guess I should say, I put a dotted line when I start doing this. Once you get pretty good at this, you might not have to, and maybe some of you are from Algebra 1. But it's not a bad idea to put this dotted line, and the reason I do that is because I know if I'm ever taking something across the dotted line, I need to cancel it. So this 56, I need to get this x all by itself, so I need to take the 56 to the other side of the equal sign. So I'm subtracting the 56, but the reason I know I need to cancel like that is because I'm taking it across the equal sign, across that dotted line. Negative 12 minus 56 is negative 68. Now, the reason I knew I did 56 first instead of the 16 is because you do the order of operations, but since we're solving, we're working backwards to find the answer. So since we're working backwards to find the answer, we actually have to do the order of operation backwards. So we actually do adding and subtracting before we get to multiplying and dividing. So now we have multiplying and dividing. Divide both sides by 16. And I know I should maybe elaborate a little bit more on that, but hopefully you remember it from Algebra 1, and I don't want to confuse you guys too much. So I divide both sides by 16. I get this answer. It's really strange. It's negative 4.25. Now, the reason it's strange is because you got a decimal. Now, one of the reasons I did this here at the beginning of this chapter is to make you guys realize that if you get a decimal, that's fine. It happens. If you want to go back and double check to make sure you got the right answer since you didn't get a whole number, I would greatly encourage that because I always want you to check your work. That'd be great if I could get you guys to do that all the time. If you want to write this as a reduced fraction, you can. So if you want to write this as negative 17 over 4, but for me, it's way easier just to type this in your calculator. If you do that, please round to 2 decimal places, unless I tell you otherwise. But again, as long as you put a fraction, if you reduce it, that's fine. I just think it's hard to reduce a fraction than just putting it in your calculator. I guess that said, some of you guys' calculators reduce fractions, so you can do that route as well. So just like the other lesson, when you have a minus 4, that means you are distributing negative. So 23 is equal to negative 12a plus 36. And just like the last one, subtract 36. Again, from this point, you guys should be pretty familiar with this. Negative 13 is equal to negative 12a. And lastly, divide by negative 12. Again, I'm just going to do that in a decimal because I think that's easier. 1.0833333333. Again, I would just round to 2 decimal places. Now, obviously, you can write this the other way around. Doesn't make any difference. Now, I have to combine like terms first. Now, this is where you're starting to see why I put this dotted line. Because a lot of the mistakes that people make is they say, oh, I'm going to add 5y here and 5y here. Well, you didn't take it across that dotted line, so you're not canceling. So this would cancel. You're not canceling like that because you're not taking it across that dotted line. If you did take it across, then that would be totally fine. You can do it that way. It's not going to help you much in this problem, but it's mathematically correct. You could do it. It won't get you the wrong answer. It won't help you at all. It's kind of like taking a step to the side rather than going forward. So instead, since 7y and 5y are on the same side, all I'm going to do is put those together. So I have a 7y and a negative 5y. I treat that like a negative. That's going to give me 2y. Just combine those. Plus 8 is equal to 24. And now I need to get the 8 to the other side, so now I'm canceling, but it's because I can do it on the other side as well. So again, earlier with the y's, we just put those together. I didn't add or I didn't cancel anything. You just took 7y and the negative 5y, put those into one number. 24 minus 8, 16, and divide both sides by 2. This one we end up getting a nice even 8. That's kind of nice. Now remember, and I should have said this before, but you can always plug these numbers back in to check your work. Now remember, when I used to say that, or when you used to have that option, a lot of times in middle school and elementary school, it takes forever because they don't let you use a calculator. Now in high school, just plug it in with your calculator. 7 times 8 plus 8 minus 5 times 8. Does that get you 24? Yeah, it totally should. But if you use a calculator, it doesn't take very long. So again, combine my like terms first before I do anything. I have negative 9 and negative 3, so that's going to be negative 12h. And then a 2 minus 10 is negative 8. And now we can start doing things on both sides of that dotted line. Now we're canceling since we're taking across that equal sign. (40) divided by negative 12 is negative 3.33 repeating. Just making sure. Okay. Make sure I didn't make any mistakes. I still probably did because I do that, but good to check. So this one, you just have equations with variables on both sides. So with this problem right now, there's 4 different things you could do. You could subtract 20 from each side, and you get the right answer. You could add 3y to both sides, and you get the right answer. You could subtract 10y from both sides, and you get the right answer. Or you could add 6 to both sides, and you get the right answer. So there's 4 different things you can do to get the right answer. So whatever you want to do, you can do. Just make sure you're careful. I always like to combine my y's first, or combine my variables first. And if you think about it, if it's easy enough to notice, if you can try to do it so you end up with a positive variable, I think that helps. So if you'd subtract 10y from both sides, you'd end up with negative 13 over here. That's fine. You'll get the right answer. I just don't really like negatives, so I added 3 instead. Now that said, the last thing I want to do is walk by your desk and have you sit there for 5 minutes trying to figure out what the best first step is. Just do one of the first steps, because all 4 of them get you the same answer. If you do them correctly, I should say. So we solve this just like normal. Hopefully you guys are getting pretty good at these 2-step problems now. 26 divided by 13 is 2. Same thing over here. So again, if I add 3b to both sides, that's totally fine. You'll get the right answer. You just end up with a negative 8b, which is great. You'll get the right answer. I just like to try to make it so we have a positive. So if I add 11 instead, that's 8b plus 9. Oh, sorry. That's not right. The b's cancel, so it's 9's all by itself, and then this is 8b minus 17. I was close. Then add my 17. 9 plus 17 is 26. Divide both sides by 8. 26 divided by 8 is 3.25. Now we have these special cases. Now, so far, all the problems we've done, we've ended up getting an answer like x is equal to something, or a is equal to something. So b is equal to 3.5, y is equal to 2, y is equal to 8, h is equal to negative 3.33. Those are all problems that get you sometimes true or one solution. I like to use one solution, but the textbook that we used to use back several years ago, they used sometimes true. I'll accept either answer. but it's one solution. The one solution is 4, and it means it's sometimes true. So the time that these formulas are true, so if I go back again, the time that this formula, number 1 right here, the time that it's true is when y is equal to 2. If y is 3, then it's not true. So sometimes it's true when y is equal to 2, but if y is equal to everything else, then it's not true. So it's not never true, because it is sometimes when y is equal to 2. So that one sneaks up on a lot of people because it's what we're used to. We see it all the time. Now, always true and never true happens when the variable totally cancels itself out. So let's go ahead and do this one quick, and then I'll explain. Do this just like we've been doing. 12x minus 18 is equal to 7. Oh, I put those together. 12x. Might as well combine these. So now I combine my variables. So I canceled 12x minus 12x cancels, but then over here we still have 12x minus 12x, so it also cancels over here. If it cancels on this side, it's got to cancel on this side. A lot of people try to say that it cancels on the left and then on the right they just have an x, and that doesn't work. So all we have left is negative 18 is equal to negative 6. So we know something is fishy when our x's, our variables, cancel completely. So if that happens, we know it's either always true or never true. It's either all real numbers or no solution. Well, this is where you look at your answer. Is negative 18 indeed equal to negative 6? No, negative 18 is not the same as negative 6, so that means it's never true or no solution. Or no solution. I don't care which way you write it. Again, I tend to like no solution better, but I'm pretty open-minded. And same thing, you guys probably guess what's going to happen with this one. 8 and 2x is 10x minus 5 is equal to 10x minus 5. Hopefully you already see something fishy now. But when you subtract the 10x's, it will cancel. So again, we already know that it's either always true or never true. It's either all real numbers or no solution. Since negative 5 is equal to negative 5, then it's always true. Or all real numbers. Now, before I move on, the one thing I will say, what that means is no matter what number you plug in for x, you could plug in 10, 34, 0, negative 8, 5.6, pi, whatever number you plug in for x for number 2, you will get something that's true. Negative 5 is equal to negative 5, 10 is equal to 10, 11 is equal to 11. Actually, ends up negative 5 is equal to negative 5. No matter what you plug in, it's always true. It doesn't matter what you plug in for the variable. Whereas this one, number 1 over here, it doesn't matter what you plug in, it's always going to be false. You'll never get two things that are actually equal to each other. Now again, the middle thing, sometimes you get two things that are equal if you plug in the right number, but those other two, it doesn't matter what number you plug in. All right, the next one is over proportions. Now make sure you remember proportions are two fractions that are equal to each other. Some people start getting confused when we multiply something like this, when you multiply straight across. This is not multiplication, they're equal. So that means we cross multiply, so we take 4 times 3p minus 1. And it doesn't matter what order you put that in. The 3p minus 1 could be first. Just make sure you use parentheses. Multiplied by 8 times p plus 9. Oh, sorry, equals 8 multiplied by p plus 9. Sorry, I said multiply. Again, the p plus 9 could go first. And then both of these, the red and the blue, could also switch. So it really doesn't matter which order you put these in, as long as you're multiplying the diagonals. 4 times 3p minus 1. And 8 times p plus 9. Now again, you need parentheses. The most common mistake is forgetting that, and then putting the answer as 12p minus 1 and 8p plus 9. So make sure you use parentheses because you have to distribute. That's 12p minus 4, 8p plus 72, and then we just go ahead and keep solving this just like we've been doing. If I was going to add 4 to both sides, you could do that. Again, I just kind of like to combine the variables first. I think that helps me. 12p minus 8 is 4p. 4p is equal to 76. That ends up giving you p is equal to 19. Again, these are a little bit harder, but you can plug those in and check. Possible. For this one, I have 2 times 7x minus 6 is equal to 3 times 3x plus 3. Again, it doesn't matter what order you put some of these things. Just make sure you're multiplying the diagonals. So 2 times 7, 2 times 6, 3 times 3, 3 times 3. Subtract my 9. Should be 5x minus 12 is equal to 9. X is equal to 9 plus 12 is 21. And then we end up with another fraction or a decimal. I always go the decimal route if I can because I think that's easier. I think it's easier to understand, and you don't have to worry about reducing. I end up getting 4.2 for that one. So now we're getting on to the last part of this. The last part of this is where you are multiplying equations that have fractions in them. Now there's several different ways to do this, and I will admit that the way I'm going to show you right now is not the fastest way. There's a little bits of shortcuts here and there, but the problem with shortcuts is that every time you take a shortcut, you are a little less organized, and I don't want you to make a really small mistake. So the reason I'm doing it this way, it takes a little bit more time. It's one extra step of writing, but it makes it it makes it so you get it a lot more accurate. It's easier to get the right answer this way. So it says multiply every term not in parentheses by the common denominator. So remember, the common denominator would be when we had problems like 3 over 5 plus 8 over 6. We had to find a common denominator. The other thing is called the common multiple. So like that one that I had 8 over 6, I don't remember, 3. Multiples of 5 are 5 times 1, 5 times 2, 5 times 3, 5 times 4, so on and so forth. Multiples of 6, 6 times 1, 6 times 2, 6 times 3, 6 times 4, so on and so forth. And we're going to list those until we get ones that match. So hopefully you remember that. That's just a quick little tidbit. Sorry, I had some other things I erased over there. So if you look, if the denominators are the same, it's really awesome because you can just use whatever that denominator is. So we're going to multiply every term by 3. Now, if you want to multiply by 9 or 6 or 18, it doesn't matter as long as both these denominators can multiply to get it. If you multiplied everything by 18, that's fine because 3 times 6 is 18, 3 times 6 is 18. But the smaller number you use, the easier it's going to be. So I'm going to multiply every one of these terms by 3. So this is where it takes a little bit of time. 3 multiplied by x minus 3 multiplied by 1/3 is equal to 3 multiplied by 2 over 3x plus 3 multiplied by 5. Now again, there's different ways you can write this up, but if you try to do it differently, for me, it's really hard because this way is good to visual. And again, writing it big and spread out, I think it makes it so you are more organized and you don't miss anything, you don't miss any signs, you don't miss any little steps. So the easy ones, 3 times x is 3x, and 3 times 5 is 15. Those are nice and easy. Now this is where some of you guys are going to do this in one step, and that's fine, but I'm going to show you how to do it in 2 steps because I think it takes a little longer, but it's easier. So when we multiply 3, or negative 3, but 3 times, I'm going to multiply by the numerator. Basically, it's 3 over 1, so that's just 3 as a fraction. Multiply your numerators and your denominators, so we end up getting negative 3 over 3. Same thing over here, I'm going to take 3 times 2 is 6, so 6 over 3x. And then now I'm going to reduce those fractions or just divide. If it doesn't divide evenly, then you did something wrong, because that's the whole idea. 3 divided by 3 is 1, so it's minus 1. 6 divided by 3 is 2, so it's 2x plus 15. So we did all that work just to get it to where now we don't have any fractions. Now we can solve this just like normal. So I'm going to go a little quickly through this because we've done a bunch of these already now. We got x is equal to 16 for this one. And again, you could plug that into your calculator, plug it into your formula, plug it into your calculator. A lot of calculators nowadays do fractions, so you could do it that way and check your work. Now again, there's a couple shortcuts. I'm not going to show those to you right now because I don't want to confuse anybody. But you can ask me after class or during class and we can go over that. Or if you already know the shortcut, you can use the shortcut. Just be careful. So this one, we have a 2 and a 7. So they're different. So we can't, it's not super obvious like the last one where we multiplied by 3. So one thing you can do is you can always just multiply those. Sometimes it works out really nicely. Sometimes you get a bigger number. But the good news is it'll always work. So to get a common denominator, you could just multiply these two together. Again, sometimes it's a little bit bigger than you'd want, but sometimes it works really nicely. Either way, it always will give you the right answer. So whether you do it that way or just find the least common multiple, it's still going to be 14. Again, 2 times 7 is 14. 7 times 2 is 14, so that's what you can always check. So I have 14 times 1/2 x plus 14 times 3 is equal to 14 times 2 over 7x minus 14 times 1. So 14 times the numerator is 14 over 2x. 14 times 3, just put that in your calculator, it's 42. 14 times 2 is 28. And 14 times 1 is 14, or again, negative 14 times 1. Doesn't matter how you look at it. And then now, again, I can reduce those fractions. I can just divide. 14 divided by 2 is 7. 28 divided by 7 is 4. And that's one extra step, but I think that's way easier to think about it that way, way easier to look at it. Not to mention, way easier to write it down, so it doesn't get super confusing. The other way, there's a lot of crossing things out. It gets to be really disorganized really quickly. There's a lot of steps to these. You don't want to make sure you don't miss any easy things. Six and divide by 3, divide by 3. I'm getting x is equal to, oh sorry, that's negative 56, that was close. Negative 18.666 to negative 18.67. Again, round to 2 decimals unless I tell you so. Now this next one, the biggest thing they're showing you with this is, remember earlier I said you multiply all the terms except for your parentheses. So we have the same denominator, so I'm going to multiply all this by 8, except for the parentheses. So it's going to be 8 times 3 over 8. The parentheses, we don't change, is equal to 8 times 1 over 8. Now again, I can explain why it's like that, but I think when I explain stuff too deeply sometimes, it gets just more confusing. So just kind of memorize, we don't multiply that by 8. Later on, once you get some higher math, maybe you'll learn why that is. But for today, I just want to make sure you know the basics. So 8 times 3 is 24. Don't multiply the parentheses. 8 times 1 is 8. 24 divided by 8 is 3. 8 divided by 8 is 1. And now we distribute. Subtract 6x. Again, I know I'm going quickly, but you can always pause it or rewind it if you need to. That ends up giving you x is equal to negative 3. So in class, I have you guys do these on your own and compare them with a partner. Obviously, if you are watching this video, you probably aren't with a partner. But again, this is a good time that you can do this on your own. Hit pause, do it on your own, and then hit play and compare your answer with me. I can be your partner. We'll be best friends. So multiply all these by 5. we get 5 times 4 over 5x minus 5 times 2, 5 times 3 over 5x plus 5 times 3. And again, I know it's a lot of writing, but I'd rather write a lot and get the right answer, or write a lot and make it easier. So that's 20 over 5x minus 10 equal to 15 over 5x plus 15. 20 over 5 is 4. 15 over 5 is 3. And now we solve just like normally. X is equal to 25 for that one. Now this one we have 3 different variables, or 3 different denominators. So again, if you want to take 6 times 2 times 3, you could. That'd be 12, that'd be 36, and that would be totally fine. Multiply everything by 36. But if you actually look between 2, 3, and 5, they all go into 6. 6 times 1, 2 times 3, 3 times 2. So the smaller your number, the easier it's going to be. But again, if you wanted to make it 18 or 36, you could, you'd still get the right answer. Sorry, writing this all out. Don't forget to multiply everything, even that 4. A lot of people forget that. So that's 30 over 6 plus 6 over 2 minus 12 over 3 is equal to 24. And again, now we can go through and simplify a lot of these. Combine my like terms, 5 minus x, 3 minus 4 is just 1x. Subtract 5. Negative x is equal to 19. Divide by negative 1. X is equal to negative 19. In this one, we have 2 variables, the 4 and the 3. Again, if you want to use like 24 would work. If you want to use 48 would work. A couple other ones in there I can't think of. But the easiest one is going to be 12. 36, that was the other one I was trying to think of. The easiest one is 12 because 4 times 3 is 12. 3 times 4 is 12. But not the parentheses. So 12 times 3 over 4. Is equal to 12 times 2 over 3. So that means we have 36 over 4 and 24 over 3. And again, 36 over 4 we can reduce down to 9. 24 over 3 is 8. And now we have a normal equation with no fractions. X is equal to 71. 71 divided by 18 is 3.944444. So I think that's the last one. If you have any questions, let me know. If I made any mistakes, let me know. I was going fairly quickly, so I might have made some little simple mistakes. But if you let me know, I can go ahead and try to take care of those. Thank you.